this video, we're going to look at a process of linear regression using the TI Nspire calculator. The table that we have below gives us some quantities demanded and supplied for a particular item at various prices. And the first part of the question that we're going to answer is to find a linear equation that will give us the price as a function of the quantity demanded. So it's important in our structure of how we're going to run this analysis that we keep in mind that the question of price as a function of quantity will be structured so that the quantity demanded is the domain or input variable and the price is the output variable. The second part of the question, very similar, other than the fact that we're going to find an equation that gives us price as a function of the quantity supplied. And again, the statement of the problem, the input will be quantity supplied and the output will be price. Generally speaking, input we treat as a variable X and price is our output variable, usually Y. In this case we'll probably call it P. So, moving right along, the market equilibrium happens when quantity demanded equals quantity supplied. So there's sufficient production on the side of the manufacturer to meet all of the demands of the customer, so no items are left in stock and nobody that wants to buy the item has to go or do without, and that's what we call market equilibrium. Okay, so what we're going to do is with our TI Nspire, and I'm using the computer software system so we can kind of see how this works, but your keystrokes on your Nspire are going to work the same way. And we're going to work within a document, so we're going to choose a page, and the first page we're going to choose is, if we go to menu, that'll give us our choices here. But we're going to choose this lists and spreadsheet menu. And the way we're going to set this up, based on our data, we had price, so I'm going to label the first column price. Okay, and now we'll input our data for the various prices that are in our table. So we input that data for price. Now moving to our second column, we're going to label that column demand. So we'll just type in demand. And as before, we're going to input the values from our data for the demand. And just a little observation, notice as the price increases, the demand goes down, and that's pretty consistent in economics that you have that inverse relationship. So finally we go to our third column and we'll input the information to the data for supply. And again, notice at a low price no one's willing to provide or supply that item, but at higher prices more and more items will be provided or supplied. And so now that our data is in place, we're ready to begin our process of evaluating the data using our regression processes. Alright, so recall we have two regression processes. The first is to find a linear equation that gives us price as a function of the quantity demanded. So to input that expression in our calculator, we move to an empty cell to the right of our data, and we're going to call up our menu, statistics, a statistical calculation, and we want a linear regression because we want a linear equation. In this case, our input variable, the X, is going to be, and we select by right arrow here, so our input variable X is demand because we want a function price as a function of demand, so input is demand, output is price, and we'll store that regression equation into F1 in our calculator because we'll use it later for some other analysis. Clicking OK, we get the information from our regression. It is a linear regression. We have our regression equation form, y equal mx plus b, and we have our two values for the m, the slope, negative 0.5, and the y-intercept b is 146. And just a little quick observation, we have an r-squared value which measures accuracy of fit, and r-squared equals 1 means there's a perfect fit, and the r equal negative 1 says that this is a negative relationship, and we saw that as the price went up, the demand went down. So we have now our linear function giving us price as a function of the quantity demanded, and that linear function P equals negative 0.5x, or Q for quantity, plus 146. And as we saw, the data fits this equation perfectly. It's 100% fit. So if we go to our MyMathLab screen, we can go ahead and put that in. And again, a reminder that we need to use the variable Q as our input variable, as the instructions say. So negative 0.5 Q plus 146, and then we're going to go check that answer, and that's good. It's nice to have that show us a good job because we like that. Now we're ready to go to our second function, price as a function of the quantity supply. Now we're ready to go back to our calculator and run our statistical linear regression. In this case, we're going to have our input variable as the supply, so we select supply for the x, and price as the y, so we'll have a function that's price as a function of supply, and this one will be stored in F2. And we run that process, we get the information, same kind of information, y equal mx plus b, with our value for m for the slope and a y-intercept of 20. R squared is 1, so 100% perfect fit, and R equal 1 indicates a positive relationship. In this case, as the price goes up, the supply also goes up. Based on that analysis, we have that the equation giving us price as a function of supply takes on the form y equal mx plus b, that slope-intercept form, but price as the function of number supplied is P equals 0.1, or 1/10, times Q, the quantity supplied, then plus 20. So that's our perfect or best fit regression line, perfect fit in this case because of the R squared equals 1. That's 100% perfect. Okay, so we'll pull up our MyMathLab input screen, and we'll put that answer in. P equals 0.1 times Q plus 20. Eventually get all those symbols in there correctly, and we'll check that answer, and again, that's nice to have that good job. So finally, the last item we need to find is our market equilibrium price. So in summary, we have our price as a function of quantity demanded, price as a function of quantity supplied, and we're going to use those two equations to determine the market equilibrium price. That's going to involve solving an equation where we set the demand equation equal to the supply equation. We'll solve for the quantity, and once we determine that quantity Q, we will use that value Q to determine the price at which we have market equilibrium. So, now just a quick reminder, we are going to solve this equation for the quantity, but in going back to our MyMathLab, we're going to input that answer as the price because the question asks us for the market equilibrium price, not the quantity. Okay, we're going to use a little graphical process with a calculator. We're going to add a graph. So we add graph, and notice we come to F3 on our function entry, and we've got our F1 and 2 that are transferred over, but the graphs don't show up, and that's a window size issue. So again, function F2 and not showing up. So we're going to now add a scatter plot. We'll have to do a little window sizing in a moment. So scatter plot number 1, we're going to choose demand as our X and arrow down, and we're going to choose price as our Y for that first scatter plot. And then we'll come back and we'll input a second scatter plot. And in this case, our X is going to be the variable that we choose for supply. And our Y variable, notice it doesn't show up under variables, so that didn't work. But we're going to noodle around and finally get back down to S2 here. Here we go. So again, for the second scatter plot, the input variable is supply. The output variable is price. And enter. Again, no screen showing up because the window size is not appropriate for the two functions nor the data. And we can fix that issue simply by doing a zoom to the data. Notice that our y-intercept is 146. That's part of the problem. But on our zoom options, we zoom data. And now we've got our scatter plots and our regression equations shown here. And move a few labels around, and we'll have the two demand and supply lines. Now you might notice that on that F2 the equation is not exactly what I had. That's because when I was in here grabbing that graph and moving things around, I must have bumped the graph and moved it just a smidgen, but it's the 0.1x plus 20. And so if you move it around in here, it'll change your equation. Now there we go, back to 20, missed it. And let's try one more time. So let's go back to our entry function, and now let's just remember, go back and fix it. Make sure it's the 20. And so now we've got our supply and demand curves along with the labels of the functions. And actually what we're looking for in this circumstance is the intersection point of those two lines. That intersection will give us an X and a Y value, input and output. And the input variable will be the quantity. The output variable will be the price. So if we go to our calculate option, one more time, let's try that. And perhaps just to analyze the graph, we're going to do an intersection and set our lower bound and upper bound. And the calculator returns that intersection as the point 210 and 41. 210 is the quantity and 41 is the price. So this process has brought us the solution we seek for the price at which we have market equilibrium. Okay, finally we're going to use an analytical or paper and pencil traditional algebra process to solve our equation where we've got supply and demand equal. We're going to find that quantity, use that quantity value to then find the price. So we go through our steps of the solution process analytically, and basically we're going to isolate the variable q on one side and the number on the other side. So if we subtract 0.1 q from both sides, that'll get the variables on the same side. That gives us negative 0.6 q plus 146 plus equals 20 after we've combined some terms. Subtract 146 from both sides, and then from here we just divide out by negative 0.6, and we get q equals 210, and that price, if we take the 210 and substitute for q, we have our price of $41, and that's the place at which we have market equilibrium. Okay, so we go back to our My Math lab and we get that final payoff, input that price, $41, and we get a fantastic correct. That's a good thing. So I appreciate you watching. I hope this was helpful to you in your data analysis. So until the next time, we'll just do another video lesson some other time. Take care.